How did the difference of squares' identity develop? Imagine two perfect squares sitting side by side. One has a side length of a, and the other b now. What if you wanted to find the difference in their areas? That question led to a fascinating discovery in algebra. The idea that subtracting one perfect square from another can be broken down into a simple product of two binomials, one with a plus and one with a minus, is called the difference of squares. This idea didn't just pop up out of nowhere. It grew from both algebraic calculations and visual understanding of shapes. In algebra, mathematicians noticed that if you multiply the sum of two numbers by their difference, the middle terms cancel out. When you expand the product of a plus b and a minus b, you get a squared minus b squared. This expansion shows that the difference of squares is always true for any numbers or variables a and b. It's like a shortcut for factoring certain expressions. But the story gets even more interesting with the geometric perspective. Think of a large square with side length a and a smaller square with side b inside it. The area difference between these two squares can be rearranged into a rectangle with sides a plus b and a minus b. This visual approach helps us see that the difference of squares is not just an algebraic trick but also a shape-based idea. Long ago, before we had symbols and equations, mathematicians used shapes to understand relationships. They drew squares and rectangles to figure out how areas relate. This geometric method made the algebraic identity easier to grasp and remember. Over time, these ideas combined, and the difference of squares became a fundamental tool in algebra. This identity is especially helpful when factoring polynomials. If you see an expression like a squared minus b squared, you can quickly write it as the product of a plus b and a minus b. It makes solving equations and simplifying expressions much easier. Plus, understanding its development from shapes and algebra helps learners see it as a natural and logical part of math. Today, the difference of squares is used in many areas, from solving quadratic equations to advanced topics like number theory and cryptography. Its roots in both algebra and geometry show how math connects ideas across different fields. Knowing how this identity developed gives a deeper appreciation for how math has grown over centuries, blending visual and symbolic thinking to build powerful tools.